The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone. It's noon. We'll get started. My name is Sharon Dooley. I'm going to be the moderator today. We have an exciting topic, some brand new technology that we're going to see in the future. And I hope you're intrigued by the title and will be intrigued by the presentation. We'd like to, as usual, thank our sponsor, Dell Software. Dell's sponsorship of this group makes it possible for us to give you a raffle every time we meet, and we are very grateful for their support. Upcoming SQL Saturdays is going to be one near you soon. No matter where you live, they're everywhere. It's one day of free training. Get lots of sessions. You get quality presenters. And find the one that's near you and sign up. They usually fill up very quickly. Summit is coming, not too long now. We have a discount code, VC15FPS6. You'll save $150. The DBA VC is going to get one free Summit Pass for every 10 people who register with this code by September 1st. Right now we have 2, and we have 9 more registrations. So we need 1 more registration using our code before September 1st, and then we'll have a 3rd one we can raffle off. Coming up on September 17th is another 24 hours of pass. Preview the summit sessions and get 24 hours of training free. It's actually a bit hard to get all 24 hours because they start bang, 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 and so you're going to miss a few minutes of each one, even if you sign up for all 24, just from switching links and so forth. There are virtual chapters of all stripes. Whatever you're interested in, you will be able to find virtual chapters that match your interests and areas of expertise. There are also some chapters that are doing global languages. So if English isn't your first language and you would prefer to attend in some other language, you can see the global chapters as well. PASS is an all-volunteer organization. You can just, when you go to the home page, and volunteer by updating your profile. Nominations are open now for the Passion Award. This is given every year to an outstanding volunteer. And you can nominate people that you think should be considered for this award. The award will be presented at the summit. And if you're not already a member of PASS, you should sign up and get your free membership and make sure you're part of the community. And now I'm very pleased to introduce George Lee, who's a program manager on the Microsoft StretchDB team. His current primary focus is delivering the best user experience for a stretch database. He's also worked on in-memory database, backup to Azure, and SQL Server security. And I'm going to now turn the meeting over to him and let him do his thing.
All right, thank you, Sharon. Hi, everybody. Thank you for coming to this session on StretchDB. This is George speaking. So today I'm going to walk through the landscape, the current landscape, the motivation behind StretchDB, the goals and the value proposition of StretchDB, and how exactly StretchDB works. If you have any questions, you can feel free to type it in. We'll see at the end of the presentation. We'll see if there's any that I haven't addressed. So let's get started. So when we talk about StretchDB, we usually like to get to know the audience a little better. When we do in-person presentations. So we want to understand, what kind of rating would you give to your organization's storage or SAN experience, with 10 being very good, excellent, no trouble, no friction, and 1 being there's a lot of frustration, there's a lot of friction, there's a lot of negotiation going on. We want to understand the cost level of enterprise storage in your organization, and we want to understand how many rows do you have in your largest tables. So far we've seen the largest tables are mostly in the billion row range, which is what we expected, and we want to understand what your maintenance and availability performance SLAs are going to are like with these large tables, and we also want to understand what if you're currently using Azure SQL databases at all. Now, this being a virtual conference, this being a virtual chapter format, we obviously cannot get a lot of direct replies, but I like you guys to keep your answers to these questions in mind, because our motivation is directly related to these to those answers. So what we're seeing today is that from a business intelligence perspective and from the decision makers perspective, they want to retain cold data. They want to retain their historical data, archival data, for as long as possible, and preferably they want to retain it forever. They want to have access to the cold data at any time, and they also want to keep IT costs down to a minimum. So they want to be able to spend the IT budget intelligently and to get the maximum bang for the buck. Now, as a DBA, what we're seeing from these requirements are, one is that because you want to keep historical data indefinitely, we see that tables are growing in size and databases are growing in size almost uncontrollably, because now you can get a lot of data in a relatively short period of time. Now as a DBA, you have to execute index and backup restore operations. So these maintenance operations are exceeding what is acceptable for your maintenance windows. Right, building an index on top of a 10 terabyte table it's slow. It's not fast, to be honest. To accommodate these uncontrollable growths, we have to buy storage frequently. We have to expand our storage capacity, and that's not cheap. And that relates to the IT budget situation we had before, because you only have a limited amount of money, and you have to be able to divide that into many little chunks to satisfy your needs. And frequently when you ask your users, what kind of data do I need to keep and what kind of data do I need to delete, your users often cannot say, or will not tell you what kind of data can you remove and what kind of data can you keep, because users want to keep as much data as possible to perform different types of analytics queries to suit their business, to suit business decision-making needs. So what we wanted to do to solve this problem is we want to guarantee that, one, cold data is always online, right? You can always access your cold data anywhere. We want to lower the total cost of ownership of storage. We want to make it a lot cheaper for you to store these kind of data compared to your enterprise-grade storage area networks. We want to be able to access cold data with existing applications. We want to be able to say, whatever business applications you have, you don't need to modify it. You can query your historical tables just like you did before. At the same time, we want to be able to make your life easy, make the DBA's life easier by increasing the speed of index maintenance, by being a lot smarter about index maintenance. We want to also have a faster backup and restore, and we want to automatically manage and protect cold data. We take security seriously, and we want to be able to say that we store your data securely. Now, this comes as with a set of trade-offs, right? So we think that some performance trade-off, some query performance trade-off is acceptable, right? So for example, if your annual reporting query runs, it used to run in 3 minutes, now it runs in 5 minutes, in 4 minutes, that is okay. We want to say that these archive data, the archive data that we're trying to manage, they're not often modified. So update and delete operations on these cold data are not frequent occurrences that warrants complete support. And we will have some functional limitations that we work to resolve. We work to resolve in successive versions. So what we've come up with is StretchDB. So what we've observed is that we have often in a database you have hot business data online. So the most recent records that you send into from your workload, and you also have archival data. So we want to be able to say you can selectively stretch your databases to Windows Azure, to Azure SQL databases. You want to be able to have transparent data movement, online data movement that doesn't take up a lot of resources and happens in the background continuously. And we want you guys to have resilient storage inside the cloud that is also secure. So we want to not change existing applications, right? So as the data movement is happening in the background, your business applications can query all your data as normal without ever being aware of stretch data is happening in the background. We want the data to be stored in the right place based on your configurations, right? So based on your corporate policy, based on your security policy, based on your SLA, and based on your total cost of ownership goals. And we want to have query processing occur in the right place automatically. So we don't want to say if you move rows off to Azure, you have to bring rows back. No, we don't want to say that. We want to say if you need results from if you need results from the rows that have been archived, the computation is performed on Azure directly, and only the result rows are brought back. So we want to be able to be intelligent about query processing. So we also want to enable you to have online operations. So if you do index operations, if you do say say an index rebuild, we want to be able to say these operations are always online, and we still want DBAs to have control over the entire database from on-premise. So access control, auditing, monitoring, maintenance, setting up policies, we still want all of that to happen on-premise, and we will manage the Azure portion. We will manage the Azure portion correspondingly. We want to speed up backup and restore, so we have a concept called shallow backup, which I will talk about later. So the shallow backup will make sure that the database backup is taken quickly, and the database backup can be restored also quickly without compromising your data integrity. We want to simplify the index maintenance, right? We want to be able to say, if you want to rebuild an index on a part of the table that's on the local side, you can do that without touching the remote side. That will reduce the amount of time you need to rebuild, to maintain indexes by a large amount. And we want to scale the cost of ownership for your archival data on Azure linearly, so you have near bottomless database storage. You can store terabytes or even hundreds of terabytes inside of potentially store hundreds of terabytes inside of Azure without increasing the complexity of management or exponentially increasing the total cost of ownership. And we want the developers that uses this data to continue to build and enhance applications with their existing tools, and we want to make application development the same. We do not want to add complexity to the application development. So how does it work? So we envisioned a couple of operations. First of all is, how do you discover and assess the fitness of a stretch database for your workload? Second, of course, is enabling stretch database on your database. Third, I'll talk about how data movement is going to happen behind the scenes, and we'll talk about how the querying will work with stretch table, and then we'll talk about how backup and restore will work with a stretch database, and I'll sprinkle a couple of demos in the middle, so we can see how exactly it is in action today in CDB 2.2. So in terms of how you can discover and assess the suitability, the feasibility for your workload to adopt StretchDB, we've put out a Stretch Database Advisor. So this advisor is bundled with the new SQL Server 2016 Upgrade Advisor. So we've redoubled our efforts on the upgrade scenarios, and we've put out a new version of the Upgrade Advisor, and StretchDB Advisor is bundled with that. So what the advisor will do is the advisor can analyze your database schema and workload characteristics for you, right? So if you connect to an instance, it will look at your operational data as well as your database schema to find out how big your tables are and the query patterns on your tables, and use these to assess whether or not Stretch Database is truly good fit for your workload. It'll also look at it'll also look at the number of potential issues that you may have when you try to adopt StretchDB. As I mentioned before, we are making some functionality trade-offs, and the StretchDB advisor will tell you what kind of a functionality trade-off you have hit with your workload. So currently it's available, and the link you can get it in two ways. One is through the download center here, and the other one is through web platform installer. So if you open web platform installer and search for upgrade advisor, it will show up for you. So I have a demo for this StretchDB advisor here. So just let me switch to my demo. So here's the StretchDB advisor. Let me open this up. So the StretchDB advisor is we built a whole new interface for it. So this is more of a scenario-focused advisor. So currently we have two scenarios working: the upgrade analyzer and the StretchDB advisor, right? So we've built in auto update. So currently mine is at the newest version, so there won't be an update notification. But if we push out new bits, you will get automatically updated. So as long as you're connected to the internet, you will get automatically updated to upgrade to the newest versions. We've also added a direct feedback mechanism, right? So you can send anonymous feedback to us directly through this interface. So we do read these feedback, and we've already done some improvements on the database connection interface from the feedback we've gotten through this interface right here. So without further ado, let me just go into the StretchDB advisor. So we've taken the page from the Azure portal, and we want to have a scenario-oriented user interface. So we've taken the Blaze, and I'm just going to connect to the local instance over here, and you can configure the advanced settings over here as well, port number and connection parameters. So let me just target this adventure or stretch database. You can target multiple databases with on the same instance with the same interface, so you can run them all in parallel. So let me just run that. What it does in the background is it's going to go into your database and do a DocFX extract. And what it gets is it gets all your schema objects, and it gets some operational data. And we will then run our code analysis on top of the extracted schema and operational data. So as you can see, it's pretty fast. It's done. We have 31 tables analyzed. And here's the interface so far. So we've adopted this quadrant wheel, right? So the vertical axis here shows the size of the table as the measure of the benefit, right? The larger the table is, the more benefit you will hit in terms of storage savings, in terms of index maintenance, in terms of in terms of the backup restore, if you stretch those tables. So on the cost side, it's more on the number of functional blockers you've hit, and it's more on the query patterns, right? So if your query pattern fits StretchDB, the cost of your migration will be low, and if your workload does not fit StretchDB, the cost of your migration will be high, and your tables will be less suitable for StretchDB. So now what I have is we have this single table, fact product inventory, that has about 7 gigs of data. That's about 3 million rows, and it's ready for stretch. So it sits comfortably in the top left quadrant, which means that it's relatively high benefit, and it doesn't have a heavy cost associated with it. So these are the best targets for you to adopt StretchDB for. Now we have a bunch of tables sitting on the bottom right and the top left. The bottom right quadrant, and we could also have some tables sitting on the top left. So these are what we call medium fitness. These are tables that are can either benefit a lot but are hard to convert, or their workload pattern doesn't necessarily suit StretchDB that much. Or we can do the bottom right quadrant, which is they are easy to convert, but they have comparatively low benefit. So they're comparatively small tables. And we also have the bottom left quadrant, which says, these are also small tables and their workload pattern don't fit. So if any table falls into the bottom left quadrant, it's best to not bother with these. So here, what we can see is that the table is ready to be part of a Stretch database, and we can go to Books Online to find instructions on how to enable Stretch database on the table, which how to enable Stretch database, which I'll talk about and demo in the later segment. But here, what we have is we can have a list of what kind of constraints that are not currently supported. So we're planning to open up. We're actively working on removing blockers and removing these functional limitations, so that we want to make your adoption experience as smoothly and as seamlessly as possible. But currently, we do not. Currently in CB2, we do not yet support foreign keys. So let's take a look, right? So we can say the advisor tool also shows you which foreign keys are on the table and which are not supported. And if you click on this link, this will bring you to the Books Online onto the exact list of limitations that currently Stretch database does not support. Now we can also export these results. So we can export it to HTML, which gives you a very nice HTML report that you can email and you can send out. And we can also export to CSV so that you can import into Excel and manipulate as necessary. Right. So that's the advisor tool. We are still actively working on it, and I'll talk about the roadmap for the future improvements for the advisor tool a little bit more a little bit more later. So let's go back to our slide deck. Where is it? Here we go. So now let's talk about how we want to envision enabling the Stretch database, right? So Stretch database by design is split into two parts. We have the on-premise part, which we have the on-premise SQL Server instance. We have the on-premise applications connecting to it, and we have the database sitting on the on-premise SQL Server instance that has two kinds of tables. So one kind of table is the hot data, the operational data, and the cold data, the archival data, are in separate tables. This is what we call the archive table scenario. The other one is that this table is a mix of hot data, recent operational data, and archive data, right? So you have a single table that, for example, you have top 10% of the rows, or the most recent, the rows that, the orders that you submitted over this year, and you have the orders that you've accumulated over the past 20 years. You have them sitting on the same table. So this is what we call the archive row or predicate-based stretch scenario. So we will support both. So when you enable Stretch database, we establish a link between the on-premise SQL Server instance and Azure. So once we establish this link, we can access the specific Azure compute resource and Azure storage resource, the storage resource on Azure to store this data. So enabling here means that we need to establish this link, provided the right credentials, make sure that the resources are provisioned correctly, and most of the time we will just handle most of this for you, right? For example, creating the remote portion of the database and provisioning creating table schemas on the database for you, but we will still need to set up certain artifacts on Azure. Now, when it comes to data movement, what we want to do is we want to have trickle data movement, right? So we want to be able to move data in such a way that, one, it doesn't saturate your network bandwidth, and two, it happens transparently, so it doesn't impact your workloads it doesn't impact your application's performance to a significant degree. So for the archive table scenario, we simply mark this order detail archive table to be stretched. So we mark the entire table to be stretched, and through the trickle data migration, we move the entire archival table over to Azure and remove the local data gradually. So you'll see that space on your database file being freed gradually. And for the archive row scenario, what we are going to do, what you need to do is you need to tell us, what kind of rows are archival rows and what kind of rows are the current rows. For example, you can tell us any row that has a completion date before January 1st, 2015 are cold rows, and any row that has a completion date after should not be archived. So the engine will be intelligent enough to determine which rows needs to move, and will automatically move the cold rows over. Right. So you see that the transaction details table still exists with partial data on the local side. And transaction details also exists on the remote side. So we want to be able to achieve both scenarios. We want to be able to accommodate both scenarios. And when it comes to querying, right? Once you have data stretched to the remote to Azure, what we want to do is we want to have transparent remote data access. What this means is if you have queries that comes from your on-premise applications or comes from ad hoc user queries that hits only local data, the engine will be intelligent enough to say it only hits local data. I'm not going to reach out to Azure, so I'm just going to hit the local data, the local order details table, hit the local transaction details table, and return my result sets. Right. So these should be correct, and these should be good enough for this should be good for the application's needs, and it doesn't incur the latency It doesn't incur the latency penalty going to the remote. Now, if we need something that requires both local and remote data, for example, I want to get, I've archived the transaction details table according to, say, anything older or anything earlier than 2015, and I want data for the year 2012 through 2015. What the SQL engine is going to do is it sees that the query needs both data from the local portion and needs the data from the remote portion. So it rewrites the query in such a way that the query executes both on the local side for anything after 2015, and it executes the query on the remote side for anything between 2012 and 2015. So we essentially are splitting the query into two parts and running both in parallel on the same on two different sides. And then we'll grab the result set from the remote, return it to the local side, aggregate it with the local, so combine it with the local result set, and then return it to the as the required result. So this means that we don't have to bring every row back to local for storage for compute, and this means that we can actually leverage the compute resources on Azure to better perform queries. So now this is all very fancy graphics. So how does it work exactly in practice? Currently in CB 2.2. So I have another demo for you. So let me just find, right here. Cool. So remember we had the AdventureWorks stretch database, right? So remember we recommended the fact product inventory table. So we want to stretch this database. Now what we can do is we've built a nice wizard experience for you in SSMS. So right-click database, right-click task, stretch, enable. Right. So we'll have to configure a couple of things. The wizard will guide you through everything. So we need to protect the credentials against any attempt to. We need to protect the credentials to connect to the remote portion. We can also select several tables to stretch. So we can see the number of rows and we can see the size in kilobytes here. So maybe I'll select fact product inventory. We'll do next. Right. So the validation here will give us whether or not the table is actually good for the table actually has any functional incompatibilities with stretch, and also validate if there are anything that we need to do before we can enable stretch on the table. So here we'll see that we need to configure the database master key, and now we'll need to sign in to Azure. So I've already signed in as myself inside in Azure, and I can select the subscription. So let me just select Halligan Project Primary. Here are a list of regions that we can select to stretch to. West US. Select existing server. We have a lot of existing servers here, so we have a filtering mechanism here. So like stretch. So as I type, I can filter. Next. So we'll need to provide the SQL database, SQL engine with the right credentials to be able to access that instance. So let me just type this in. This should be the right ones. And we can also configure Azure Firewall to open up the right IP addresses for stretch database. So I'm just going to do 700.101.107.255.255. So these we can add multiple blocks to the firewall configuration. So you can add multiple firewall rules in one batch. Now, here's what the wizard is going to do, right? So here the wizard will create a new master key. The wizard will stretch the table. The wizard will use an Azure subscription. The wizard will use West US. Use a server like stretch. We'll have like as the admin, and we'll add firewall rule. So once I click finish, the operations will be performed in sequence. Now, the wizard is built on top of this wizard is built on top of SQL Server Management Objects, small, and you will be able to also use small scripting inside PowerShell to create this with a combination of Azure PowerShell and SQL PowerShell. And this wizard, the action of the wizard will be fully scriptable inside PowerShell, and so it will be fully scriptable inside PowerShell. So because we do while the wizard is executing, because we do trickle move, right? Moving 7 gigs of data is going to take a little bit of a time. See if this is done. So yes, so now this is done. And what we can do is we can go into this database and do select star from sys db RDA migration status. This is the DMV that shows me the what kind of that shows me the operations that has taken place. Now, what we do is this usually takes a little bit of time because we run this in the background at certain intervals. So it'll not immediately show up, but eventually it will. But because this takes a little bit of time, we've already stretched a database with data on the remote side. So let me just see here, select star from sys remote data archive tables. And so let me just turn this on first. Yeah, so this is how you stretch a table in SQL, in T-SQL. And let me just say select star from sys remote data archive tables, and you can see that the object ID here. You can see the object ID of the patient history table. You can see the remote table name. You can see the remote database name here, so that this table is stretched. And we can check the migration status. So you can see that a couple batches have already completed. Now, because this table has already been completely stretched, there won't be any migration. There won't be any rows that'll move. So let's see. So let me turn on. Let me show how querying is going to take place, right? So let me just include actual execution plan here, right? And execute these queries. So select count for both. Right, so the first query is already completed. The second query is also completed. And you can see from the original and the stretched tables, both of these will have the same row count. And for query one, you have streams. And for query two, you see the remote query operator over here. That's different, right? So for the remote query operator here, we actually are sending a part of the query over to Azure. So this indicates that that part of the query is executed on Azure. Right. So this is the difference between the query plans that we want to highlight. Right. So let's do a more complex query. This operations original. It'll take some time. Yep. And you see we have returned 10,955 rows. If I copy this over to a new query that executes this with the query plan on. So this is the stretch table query. It'll take a little bit longer because it has to travel to Azure and come back with the result set. So it'll take a little bit longer. Yes, this is the old one with the execution plan. So here we don't see here with the local table we don't see the remote query operator here. Let's check on the older the table that I just stretched in the VentureWorks stretch. Check on that. You can see that some rows are already moved. Some rows are already moved into to Azure. Right, so we've moved about 10 batches so far. So this will take a little bit longer than this will take a little bit longer. So now meanwhile we can check the space, right? So if we see there we go, that's done. So you can see the two queries. They have the same results, right? They have 10,955 rows, so about 11,000 rows, right? So both of them have 11,000 rows, and if you examine the result set, do like a compare, you'll see that the result sets are identical. So we're running identical queries over a stretch table and unstretched table, and we have the same effects, except the stretch table runs a little bit slower. We can also check the space consumption for our stretch tables. So the original table has 1 million rows. It takes about 67 megs, right? The stretch table with all its rows still has 1 million rows. Now, if we run something called the remote only, we run the space use with the parameter local only, which means that we only see the data on the local. We only see the data on the statistics on the local side, and you can see that we have no rows on the local side and very small space, very little resource space consumption here. So this means that almost all of this data is now offloaded to remote, and local here we only keep very little data. Okay, so we can also control whether or not a table will migrate, whether or not table can migrate data over to Azure. So I can also turn this off. We can also turn this off. So once I turn this off, data will no longer be migrated to Azure. So that's the demo for Stretch Database, at least the enabling and the querying part. Okay, so backup and restore. So the way that we want to look at backup and restore is that we want to enable what we call a shallow backup. Now, a regular backup and restore will have all of your data, whether or not it needs to be backed up, right? So with archival data that doesn't change much, that data is going to be backed up in every full database backup you take, right? So what we want to do is we want to have something called a shallow backup. The shallow backup only includes tables inside the local portion of the database, right? So it only includes the hot, not archived version, not archived data. So it also contains pointers to the remote portion, the archival data. So that data is not actually backed up inside your local backup file. So when we do a restore, we restore the hot portion and we reconcile with the remote portion so that you have so once after you finish the restore, you will have your database state back to exactly at the point where you've taken the backup, right? So this also reduces your backup size, and as long as you have a small backup, you will be able to back up and restore your database quickly. So we don't have a lot of time, so let's go through some roadmaps that we're thinking about, right? So currently in CDB 2.2 in our monthly releases, we do support row-level security with Stretch Database. So you can enable row-level security on a Stretch table, and you can stretch a table with row-level security enabled on it. So we're actively working on a couple of things, right? So one is predicate-based stretch, right? So this will be functional. This is one of our key scenarios, and this will be functional in the next milestone. We have physical in the next major milestone. We have physical schema changes. Here, what we mean is we want to enable creating indexes on top, creating and dropping indexes on top of a stretch table, and we want to enable index maintenance operations on top of the table. We want to continue to invest in performance improvements, both in data migration, right? So we can migrate data quickly, and both in query performance, right? So increase the performance of queries across both portions of the table. We want to invest in PowerShell and SMO support. As you've seen, the wizard is built completely on SMO, so you will be able to use SMO and by extension PowerShell to do exactly what we've achieved here with the wizard. So you can script every stretch database related operations with a PowerShell script. We want to be able to enable always on with stretch tables and stretch databases. We want to enable make sure that your existing HDDR solutions based on always on still work, that uses always on still works. We want to enable the update and delete archival data, and we want to look at how we can enable foreign key constraints. And we understand that currently the Azure SQL DB model may not exactly suit our stretch database needs. So we want to be able to separate the compute and storage charges for you inside Azure, so that you can pay separately for compute and storage and scale up and down your compute as you see fit. And we will have in the Stretch Database Advisor some recommendation mechanism to give you an estimated amount of resources you'll need. And we want to refine the advisor recommendations according to your workload patterns. We want to continue to be able to get more accurate recommendations from your work. We want to be able to get more accurate recommendations for the advisor tool, so that you have a better picture of which tables are suited and which tables are not. And we have a whole slew of feature support coming in. As you know, SQL Server 2016 is not just StretchDB. We have a lot of other features. For example, temporal tables. For example, always encrypted. For example, AAD, Azure Active Directory integrated authentication. Right. So we want to be able to flesh out these stories and make StretchDB as easily adoptable as possible. So we're continuing to invest in these areas as well. All right. So we'll target. So in summary, Stretch Database is designed to work with most of the existing applications with very little code change. In SQL Server 2016, we'll target existing history tables, the archival table scenario, and we want to target cold data inside the mixed table. Right. So please, if you think that StretchDB is the right thing for you, if you think that you have the opportunity to either play with StretchDB or leverage StretchDB, try out the advisor tool against your workload, and send feedback through the mechanism inside the advisor. And if you are interested in working with us to get the first to get the early adopters experience, to get the early bits, to play with this and to see if you can actually leverage this for your workload, you can join a TAP program. So if you join the TAP program, you'll get you will get a lot of attention from us in terms of how your workloads are, how will StretchDB benefit, what you need to deploy StretchDB in production. And it's all just a click away, and all you need to do is fill out a survey, and we'll work with you to get that done. All right, cool. Do we have Any questions?
Oh yes, you have lots of questions.
We only have 6 minutes, so I will try to answer as many as
So
I can.
and I can save the question list and send it to you too.
Awesome, awesome.
And also, I need to give Shamik a little chance to speak. He couldn't get into the meeting earlier, and he needs to talk about upgrading. But
Okay.
let's do the questions relevant to George's talk first.
Sure.
Can I have partition switching into the StretchDB?
Partition switching into the StretchDB. We've looked at stretching the tail end of the partition. It's an interesting scenario, and we're looking at it. I can't make any promises as to when that's going to be delivered, but we're interested in stretching partitions.
I think there's a lot of questions about how you do this split. The question says, I'm interested in the ways you can manage the split. User-defined row aging, percent of rows, other.
Yeah, so a couple of things that, so with the archive row scenario, we are targeting, a couple of primary kind of predicates that we speak of. One is based on certain fixed values, right? For example, if your order has status completed, abandoned, canceled, or returned, or whatever, or certain values like that. So you can define a predicate on the table, and the engine will use that predicate to evaluate. Now, the other one, and this is the harder predicate to evaluate, is we want to define a rolling window, right? So this is what we call a rolling window. Is we want to be able to say, according to this column, this row is a certain age. For example, this row is 1 year old, this row is 2 year old, this row is 3 year old, right? You can define a predicate like that, and we'll be able to say, okay, so this row currently is 1 year old, we'll move it over to Azure, and that row is not 1 year old yet, we'll keep it on premise. So these are the two primary scenarios that we're targeting. If you have any crucial scenarios that are important to you that we're not covered, that is not covered with these two primary use cases, please let us know, because we're extremely interested in how predicate can be used in other manners.
Okay, let's see. What's going on behind the upgrade advisor analysis? What parameters are checked to make sure to determine which tables are ready for stretch?
Yes, that's an excellent question. So what we're looking at is, one is we're looking at the schema of the tables, right? So we're looking at how many functional incompatibilities that we have with Stretch database, and the second thing that we're looking at is actually the size of the table, right? So as you see, we do make recommendations. So that comes from our syspartitions, right? So it comes all from the DMVs that we have inside SQL Server. Now the third thing that we're looking at is actually access patterns, right? And we're still in the process. We're in the process of refining the access patterns, refining the query to recommend based on the access pattern. So we do look at index operational stats. So we do look at how many times the tables are inserted, updated, deleted, or queried inside for each index, and we want to make recommendations based on those. So so we're interested in these query patterns in your workload and what your archival tables query patterns look like so if you're interested, you can you let us know, and we'll definitely take that into account.
If you have archive rows in Azure storage and the link to Azure goes down, can you still work with the local data?
Yeah, the point of reference right now is yes. If you have rows in Azure and the link goes down, the engine should be smart enough to say your query doesn't require remote data, so we'll let the query succeed. Or if your query does require remote data, we'll let the query fail because we will not be able to return you the results from the remote portion. Now, we do want to make this Azure link as resilient as possible. So we do want to build in retry logic and all the standard procedures necessary to make sure that these queries fail as infrequently as possible. So yes, in short, yes, the queries against the local portion should still succeed. If the should still succeed by RTM time if the link to Azure goes down.
Okay, what triggers the move of data to Azure?
So there are two kind of triggers here really. One is one is classifying a row as eligible, and that's how you define it, right? So if you define the whole table as eligible, every row inside the table will automatically be defined as eligible. Now, the second thing is when the rows are moved to Azure. So we run the migration batches in the background on an interval. So it's time-based and it's kind of round-robin-like. So we do this trickle move fairly across all your search tables, across all your rows. So eventually they'll complete, right? And there's really no well-defined order in which the rows are moved. As long as they're eligible, they will be moved to Azure eventually. All right.
Can you enable change data capture on stretch tables?
Currently, no. If this is very much necessary or crucial to you, let us know. So I think do we have time for one last question?
I think so. And
okay, cool.
It's a good one. Isn't there a huge latency to retrieve large volumes of data that are stored in the Azure StretchDB?
Yes, and so latency here consists of a couple of concerns, right? So one is the network latency, right? So if you put your data in the right data centers, right? For example, for me right now I'm sitting on the West Coast, so I put it on the West US. I could minimize that network latency, right? The second thing is how much computational resource you get if you do, if you retrieve how much computational resource you get for the Azure query to run, right? So if you give it more computational resource and the plan is to let you to be able to scale automatically scale dynamically, not automatically, still dynamically how much resources you provision for Azure Compute. So that'll also reduce latency. The third one is bandwidth. Now that one is based on your network conditions, right? So if you retrieve large quantities of data from Azure, say a couple of gigabytes, that's going to take a while if you don't have a good network latency. So that is also there, right? So we can minimize it by putting it into the right geographical location and giving it enough compute resource on Azure for the Azure query to run quickly.
Okay, thank you very much, George. I'll send you the full list of questions. And I want to now give Shamik a chance to make his speech. And so go ahead, Shamik. I've made you a presenter so you can do your thing.
Awesome. Thank you, Sharon.
Okay?
All right, thanks. Thank you. So if everyone can hear me, I don't have to present anything. This is only 2 minutes of your valuable time. I'm a program manager on the SQL Server engineering team, and the engineering team has set aside a good 2 months to actually just sit and talk to customers and understand their frustrations with upgrades and their motivators to move to the current version of SQL Server. If you, an individual, has any issues with upgrades, whether you've upgraded from an older version to a newer version, or you're even thinking about it, we would like to hear about it. We would like to engage with you over a 30-minute call, you and the engineering group, to understand what's really blocking your upgrades, what has been your upgrade experiences so far, and how we can improve our product going forward. If that would require us to have frequent engagements with you, we will do so. So I essentially have two small surveys that will only take 2 minutes of your time to fill. If you are an independent software vendor, I would request you to go to http://aka.ms/SQLisvPulse, SQLisvPulse. If you are an enterprise, medium business, startup, developer audience, and you would just like to reach out to us, you should go to http://aka.ms/letstalksqlserver, LETSTALK and we will engage with you over a phone call. If you don't want to fill out the survey, you want to reach out to me privately, send me an email. My email is shamikg@microsoft.com. That is shamikg@microsoft.com. It's a good opportunity for us to reach out to you. It's a good opportunity for you to talk directly to the engineering team here. So I look forward to hearing from you guys. That's all I have to say.
Thank you, Shamik.
Thanks.
And we have one final thing, and that is for me to announce that David Myers of the FAA is our raffle winner today, and Pass will contact him about the prize. And that's it. Thank you all for coming, and we'll see you in a couple of weeks. And you'll get emails about what's going on. Thank you, George, for presenting such an interesting new technology.